All right, guys, no cheat from yesterday. All right, guys, I think this is where we stopped yesterday. Yes? Perform the given operation. All right. So these next few here, we want to perform the following operations. So they want us to add the two fractions together. But for us to be able to add two of these fractions together, the denominators have to be the same. And to get them to be the same, well, for the one on the left, 1 plus cosine of theta needs sine of theta. So we're going to multiply top and bottom by sine of theta. The one on the right needs the 1 plus cosine theta. So we're going to multiply both sides by these two here. The left side by sine of theta over sine of theta, and the right side by 1 plus cosine of theta. And if we do this here, the numerator of the one on the left, our sine of theta times sine of theta, is going to be sine squared of theta. Now the denominator, if we multiply by sine, and we actually multiply through, it wouldn't give us anything squared. It wouldn't give us anything we can line up with, say, the Pythagorean identities, our sine squared plus cosine squared, or our tangent squared plus 1, or secant squared of 1. We don't get any of those terms. Would we agree with that? So, since it's not going to really help us too much, we're just going to leave it as sine of theta times 1 plus cosine of theta. With the next one, we will have a case where multiplying through is going to be helpful. But for this here, multiplying through or not, it's going to be better than not. On the right-hand side, we have cosine of theta times 1 plus cosine of theta. Well, our cosine of theta times 1 is cosine of theta. Plus cosine times cosine is cosine squared of theta over our sine of theta times 1 plus cosine of theta. Questions on how we got to this point here? The denominators are the same, so we can add the numerators. Do we have any like terms between our two numerators? Well, no. We have our sine squared of theta plus cosine squared of theta plus cosine of theta. Now, I rearranged them in this order for a particular reason. Questions on any of this so far? Sine squared plus cosine squared. Is that one of our identities? It is, isn't it? Because what is sine squared plus cosine squared? 1. So really, with this here and simplifying this here, we can rewrite or change our sine squared plus cosine squared into 1. So in the numerator, we have 1 plus cosine squared. The denominator is sine of theta times 1 plus cosine theta. Questions so far? Can we simplify? Is there something in common on top and bottom? What? The 1 plus cosine theta, that entire those two statements will simplify. And the only thing we have left on bottom is sine of theta. What do we have left on top? 1. Because whenever we're simplifying something on top and bottom, it never reduces to 0. It reduces to 1. Do we feel comfortable with this so far? Yes? Can we rewrite 1 over sine of theta? Yes, it's what? Because that is a little simpler. We don't have a fraction with a trig function on bottom. We just have cosecant. That's it. It's kind of nice, but also frustrating that that entire original statement is just cosecant. Would you all kind of agree with that? That our starting statement of sine over 1 plus cosine over sine is the same. We'll have the same value as cosecant. It's kind of a little bit weird that it works that way, but one over 1 plus sine of theta plus 1 over 1 minus sine of theta. Just like the previous one, we need to get the denominators to be the same for us to be able to add. So the one on the left, we're going to multiply top and bottom by 1 minus sine of theta. Because that's what the one on the left's denominator, or the one on the right's denominator is. The one on the right, we're going to multiply it by 1 plus sine of theta. Now the numerators are nice, because 1 minus sine of theta times 1 is 1 minus sine of theta. And our 1 plus sine of theta times 1 is 1 plus sine of theta. That's nice. Now our denominators, 1 minus sine of theta, 1 plus sine of theta. Does that look kind of familiar? Because there's a specific thing that we have with this here. It's a difference of perfect squares. Our factors, 1a plus b times a minus b. Difference of perfect squares there. Do we kind of see that? No? Yes? Not really? So, difference of perfect squares. A squared minus b squared shows up as a plus b times a minus b, or a minus b times a plus b. So if we have the two terms and just a different sign, something interesting does work. And let's see how this works. I'm going to do the first one out. Because if we actually multiply this out, 1 times 1 is 1. 1 times sine is plus sine of theta. Negative sine of theta times 1 is negative sine of theta. We haven't finished this out, but what's happening to our sine of thetas? They're going to cancel because we have a positive and a negative, same value. That's going to be 0. Negative sine of theta times sine of theta is going to be negative sine squared of theta, which is going to leave us with what? 1 positive sine of theta, negative sine of theta, these simplify to 0, leaving us with 1 minus sine squared of theta. In the way we got the other one, well, they're both the same. We're just multiplying 1 plus sine of theta and 1 minus sine of theta on both sides in the bottom. Since I got it for one, it's going to be the same for the other. Now we can add the numerators. We'll get back to why that's important here in a second. Because we can add these because they are the same. On top we have 1 minus sine of theta plus 1 plus sine of theta. Negative sine of theta, positive sine of theta. That becomes 0, yes? Leaving us with 1 plus 1. So the whole numerator simplified to 2, yes? Now I mentioned it just a second ago that 1 minus sine squared is kind of important or kind of useful, yes? Well, that whole identity for the reference page that I've given you so far, it's got a full front and back and a front. And we've only really used, for most of this, 3 of the equations, yes? And that's our sine squared plus cosine squared is equal to 1, yes? And we've used this one a few times. We've used it as this here, but we've also used it as what? Sine squared of theta is equal to 1 minus cosine squared. So if we get 1 minus cosine in one of the formulas, I can replace it with sine squared, yes? But that also means that cosine squared of theta is equal to 1 minus sine squared. So if we had 1 minus sine squared show up in a problem, we can replace it with what? Cosine squared. So here I can replace the bottom with. Can we see why this one's nice, or works out better to actually multiply? Because if we did the last one, it would just be, I can go back to it. Here, this here would have just been sine of theta plus sine of theta cosine theta. But to simplify, I'd have to factor the sine back out so we get that 1 plus cosine to cancel. Here, if we multiply it out, we get this 1 minus sine of theta, which is cosine of theta. This actually simplified. Kind of a way to see it is if we have that sum or difference of perfect squares. That's the only big thing with that. Does that make sense? Kind of, sort of, and it's, I think this is very similar to factoring. And the more that we do this, the more that you'll see how this works. One over cosine is secant. So we can actually pull the cosine out of the bottom to the top as secant. Again, if something doesn't make sense, ask or stop me, because this is bizarre. This is weird that this works this way. Because out of everything we've done up to this point, especially in Algebra 2, these formulas, we used them, we plugged in the information we needed, and got our answer. Here, we're starting to use formulas, and we're starting to tweak with them, mess with them, monkey with them to make them be something that I want or can use, which we're not used to. This is very different. Questions on this here? When factoring trigonometric expression, it is helpful to find a special polynomial factor form that fits the expression. That's what we've been doing. On occasion, factoring or simplifying can be best done by first rewriting the expressions in terms of just one trig function or in terms of only sine and cosine. That way we get some similarities across it. We want to rewrite this. So it's only in, so it's not in fractional form. Well, we know that sine is 1 over cosecant, and cosecant's 1 over sine. Yes? But 1 plus sine we don't have anything for. So it'd be nice if I can rewrite it as a single expression, a single term, yes? And out of all these theorems that we've had so far, the most helpful have been the Pythagorean. The sine squared plus cosine squared equals 1. Our tangent squared plus 1 equals secant squared. Our cotangent squared plus 1 equals cosecant squared, yes? So it'd be nice if I could have sine squared, not sine, yes? Well, I'm going to multiply this whole thing by 1. Not just 1, a fancy version of 1. Because as we just saw with the last problem, we had 1 plus sine, yes? What did we multiply it by that ended up making it nice? 1 minus sine, yes? We multiplied it by its conjugate. So whenever we have these fractions, whatnot, we can multiply it by its conjugate, specifically the denominator, to get this to simplify. Because what that will do is the numerator is nice. 1 times 1 minus sine is 1 minus sine of x. The denominator, 1 plus sine of x times 1 minus sine of x, would be what? Because really what we're doing is 1 times 1, which is 1. 1 times negative sine is negative sine. Then from here we do sine times 1, which is plus sine of x. And then sine of x times negative sine is negative sine squared of x. Okay. These cancel and we get to 1 minus sine squared. So I skipped that step partially because, well, we just did it, but also questions. So we feel comfortable with this so far. Okay. And now, again, we're wanting it so it's not a fraction, that there's nothing in the bottom. And the reason, part of the reason we're doing this is because if I can rewrite that 1 plus sine as a single term, a single expression, then we can use our reciprocal functions. The 1 over, sine is 1 over cosecant, or cosecant is 1 over sine. I can actually bring it up to the top. I can remove that fraction. But as it is 1 plus sine of x, there is no expression that I can just move it to the top, or I can flip it. But if I can turn it into 1 minus sine squared, as we just saw in the last one, this is equal to cosine squared of x. Now we have the ability to rewrite it and change it. Because what could we change this cosine squared in the bottom of the fraction to become? Because cosine is what? 1 over secant, yes? So, confused? Okay, and again, so. And some of it feels that way. So, the biggest thing is when we start here, again, they just don't want fractions, yes? Now, according to our reciprocal functions, I'll get a new page. Sine of x is 1 over cosecant of x, yes? Cosecant of x is equal to 1 over sine. And we have all of these here. So if I had 1 over sine, I could rewrite it as cosecant. Well, that's not what we have. I mean, if I had 1 over, say, sine squared of x, well, that would be the same as cosecant squared. The power doesn't matter. is that I could rewrite as 1 to the other and get back there, yes? Now, of all of those reciprocal functions, do any of them have 1 plus sine or 1 plus cosine, 1 plus c? We don't have that. And that's what the issue lies in, just being able to rewrite it. But, that's the previous slide for that. And I'm coming back to here mainly for these three here. Specifically these two here. Because if I can get the bottom of that fraction into 1 minus cosine or 1 minus sine squared, 1 minus cosine, 1 minus sine squared, I can change it from these two terms with a subtraction into a single term. Because sine squared in the bottom, I can rewrite it as cosecant on top, or cosine squared on bottom. We can rewrite it as secant squared. And I've gotten everything out of the bottom of the fraction. We don't have the fraction anymore. But for me to be able to use it or do anything with it, I need something like this or here, or specifically this sine squared, this cosine squared, secant squared, tangent squared, for me to be able to start manipulating those functions. And again, that's why this is so weird, if that makes sense. Because again, I think, as you said, that it hits it on the head. It feels like I'm just doing whatever I want with these. And really, it kind of is. I'm manipulating them so that they do and behave the way I want them to behave and get the outcome I want, because they do have that flexibility to them. And I think some of our other math classes, and there's nothing wrong with this, we've had formulas be so structured and we don't touch them. Now that when we actually do, it really throws us off. But I think, does that answer? And it's really based off the setup, how we want to do it. And it's not always intuitive that, okay, with this setup, I'm going to do multiply by 1 minus sine. And we can do this partly because 1 minus sine divided by 1 minus sine is 1. Anything divided by itself is 1. So we're not changing it. It looks different. Okay? So we kind of there. The other thing that makes this odd or bizarre, and I spoke with Mr. Matney about this earlier, is that this is one of the few times answers may vary shows up a lot. Even though it's a set equation, answers may vary for this one here. Because we said from here, I'm going to split the screen, we can really say that we're taking the numerator here and multiplying it by our, I'll write it out so we can see this step by step. 1 over cosine squared of x. I'm doing this as an in-between step, okay? You can just, the way if you look back on it, you see where we're going, because it's going to seem like a jump, because really 1 over sine, or 1 over cosine squared is secant squared. Because that's just definition reciprocal. I wrote that in between step because I feel like, especially looking back on it, going from 1 minus cosine squared of x here, all of a sudden to here, might seem a bit much. And really, we can say that is the answer, because do we have any fractions left? No. We can multiply through, and we can say that this is secant squared of x minus sine of x times secant squared of x. I mean, no fractions. That's, we did answer the question, yes? Again, as I said, answers may vary. Questions on this here? Yeah. Yes. And funny enough, because this is straight from the textbook doesn't do either one of those. Because again, fractions, we added them together. We can also split them back apart. So what this is saying is that we have 1 over cosine squared of x minus sine of x over cosine squared of x. So we're comfortable with saying that there, yes? First part's easy. That's just secant squared of x. Now this seems very odd. Why in the heck I would do this? What's sine over cosine? It's tangent, yes? So really what we can say is secant squared of x, but this first one's tangent of x, and the other one is secant. And here, that's technically the correct answer. I am not looking for all of these. I'm showing you these because, again, there is more than one right answer. So if y'all are checking, because again, making sure y'all did it right, you worked on it, and one of y'all gets 1 minus sine of x, that quantity times secant squared of x, that is the right answer. One of y'all could get secant squared minus tangent times secant. Or y'all can get secant squared minus sine times secant squared. I mean, all of these are the correct answer. And like we saw the other day, when we graphed them, if we graphed all three of these, they would line right up. They will keep giving us the same output value. They are the same answer. So just because y'all don't line up, when you're looking and making sure you did the homework problems right, just because you don't get the same form doesn't mean one of y'all's right, one of y'all's wrong. They could very well be the same answer, because it's just on how we approach it and how we simplify. Does that make sense? Hopefully that, and again, if you're very not sure you got the same one and y'all want to ask. Email me and ask. I will verify and make sure that they are all the same. Questions on that there? I think we've got, what, 5 minutes? And funny enough, we can actually, I think I can get this one done in time, because we'll go through this. If y'all are still have a lot of questions, we can redo it on Monday. Okay? The top, we do have cosine squared, yes? And we want to get rid of the fraction. Well, according to the trig, or our Pythagorean identity, cosine squared is the same as 1 minus sine squared. That seems like an odd jump because we went from 1 to now 2, yes? But 1 minus sine squared is a difference of perfect squares. And I could factor it to 1 minus sine times 1 plus sine. And this is all over 1 minus something in common on top and bottom, yes? Now, would it have been wrong to have multiplied top and bottom by 1 plus sine of theta? No, we could have gotten there, but we would have had to do a lot more simplifying later on to get it to be there. That's one of the nice and not nice things about trig, is that there's more than one way to get to the answer. However, the other ways might not be as nice as some of these here, like trying to get from here to Siloam, because we can go east, hit the roundabout, go south. Or I can try to go the straight line from here to Siloam but I'm probably going to be running through a lot of people's fields, through a lot of fours up there. I can get there. It's not as nice, and it's going to be a lot more work, but there is still more than one way to get there. So